Welcome everyone, also from my side. My name is Johannes Hiltner. I'm Director of Product Management here at STEMMER Imaging. And I welcome everyone to this pretty quick introduction of STEMMER Imaging's new modular embedded ecosystem. So our goal with providing a complete ecosystem is to support you, our customers, all the way to a perfect final embedded solution for your needs. Before I go more into details, I want to give you a quick overview about how we see the embedded market in terms of low volume, mid volume to high volume. So on the very low volume market, we see standard industrial applications using a standard PC, standard cameras. They are typically lower in volume per application or per customer. They typically have a higher cost per unit, as it's typically high-end computing units, high-end cameras. But those also come with a lower level of customization and lower level of integration depth due to the fact that one can use commercial off-the-shelf standard products, but also standard software packages such as Sherlock or Merlin, for example. And the more we move into the embedded world, the world gets more complex, as on the second to the left, for example, we talk about standard development kits, which many people out there provide. Those are typically standard interface boards for the standard CPU units, which also provide standard interfaces. But then we can get really deep into embedded with embedded boards, which come with a sensor attached to it, for example, or the more we move to the right, we see highly optimized embedded sensor boards. And one example for that could be the Firefly, which Salem just presented from FLIR, for example, which is a highly dedicated machine vision smart camera, highly optimized for one specific algorithm or one specific task. And on the very right, there are, let's call it sensors and interface boards, which are highly optimized for a very specific imaging task. So the more we go into the level of customization or the level of integration depth, also the costs per unit get lower, but also the volume per application gets bigger. And especially with those two parts in the middle, we see some downsides. For example, those standard development kits, they typically provide standard PC interfaces, USB, Gigabit Ethernet, HDMI, just to emulate a standard embedded PC. We typically don't see long-term availability, and those boards are typically not suitable or not meant for higher volume applications, for example, due to availability or due to their form factor, for example. The one more to the right, those are more deeper integrated embedded devices where we see a higher engineering and integration effort. It's because there's most of the times customized board level design necessary, but also specific algorithms which need to be optimized for specific hardware units. And those are then highly optimized for a dedicated application and thus not really suitable for a broad range of applications. So exactly in between those two rows there, we see a perfect fit of our STEMMER Imaging modular embedded ecosystem, as our offering compensates for the disadvantages from both sides, one from the lower side, also from the higher end side, because this board, it offers all necessary interfaces for a very broad range of machine vision applications, and more about that in just a second. You can use standard Linux programming skills and standard off-the-shelf software packages, for example. And due to the form factor and due to the availability, we see that there's room for volumes in between, starting at 100 pieces per application up to 2,000 pieces per application. So now I want to give you a better overlook and a better insight about our modular embedded offering. On the left side, you see our modular embedded carrier board, but our offering is way more than just the simple carrier board. and we describe our offering with basically 5 major USPs. The first USP is that we provide a full-featured carrier board with a pretty broad and flexible GPU selection, which allows easy retrofit, for example, in your hardware setup, and also allows for pretty easily scaling up the CPU power whenever needed for your specific application. So it's quite easy to just find the right processing hardware, processing power for your specific application. Besides the carrier board, we also offer a pretty broad range of multiple interfaces. This one, of course, allows for flexible hardware selection, but the board itself comes with 2 10GB interfaces. We also implemented TCP Offload for that. I will explain this a little bit more in detail in just a second. We provide 2 USB 3 interfaces, and we also provide 2 MIPI CSI interfaces, which can be addressed using GenICam compliant software. So despite those pretty broad interfaces, we are also able to provide customized transport layers for nearly any kind of camera. We have this knowledge in-house. So whenever you have the need to interface a very dedicated or a very specific camera into your application, just get in contact with us. So switching over to the third USP of our ecosystem. Our ecosystem basically is manufacturer independent. So this allows for maximum flexibility again. To make it quite obvious, no matter which color the camera has you want to attach to our embedded system, you get this camera very likely from STEMMER Imaging. So with this one-stop shop, we can select the exact camera needed for your application. The board itself fully supports GigaVision cameras, fully supports USB 3 vision cameras, and for dedicated cameras, you also provide a GenICam compliant MIPI CSI 2 interface. So the fourth topic there is that we also provide a pretty powerful software toolbox. So off the shelf, we ship every carrier board with the CVB Image Manager pre-installed. And the CVB Image Manager, it comes with a generic driver stack, which is fully GenICam compatible. So without the need of any additional programming, you are able to very easily plug and play any camera with nearly any kind of interface and just make use of this image acquisition engine from STEMMER Imaging. The software package also comes with dedicated deep learning and machine learning functionality, which can be used for customized application-specific image processing tasks. And it also comes with image compression and image streaming functionality. Image compression, so there's off the shelf the H.265 streaming conversion integrated, and it also comes with a GigaVision server, allowing the application developer to visualize the device as a video stream or as a GigaVision device by itself. So with this powerful software toolbox and driver stack, this basically allows 0 to none implementation efforts for camera integration into our ecosystem. So last but not least, STEMMER Imaging is not only providing the carrier boards and the cameras and the software, which is hardware and software combined, but STEMMER Imaging also provides a pretty broad range of application-specific and value-added services. So starting from project consulting, even to co-development, whenever it comes to highly sophisticated application development, for example, but also down to assembly and configuration services. So with this service packages, our customers are able to speed up the application development. So it's a clear time saving there. With project consulting, for example, we make sure that our customers select the right hardware combination, so they get the security that they have the right products decided. And this basically at the end saves time, so our customers are able to focus on their core business, and STEMMER Imaging basically takes care about the rest. And with our assembly and configuration services, we are even capable of providing turnkey solutions, which allows for easy plug and play setups for our customers also. So this is a very quick overview about the 5 core USPs of our modular embedded ecosystem. In the next 10 minutes, I want to talk to you about 3 topics a little bit more in detail. One is the TCP offload functionality, which is available with the board. I want to talk about the MIPI CSI2 over GenICam, as well as the image compression and streaming capabilities. When it comes to TCP offload functionality, this is an extension of the GigaVision standard, which we developed together with our partner Allied Vision, which is basically a hardware accelerated capability of unpacking the packages from the TCP protocol without the need of CPU processing power. So this allows for maximum performance at very low CPU load, and this allows also for up to 1 GB of sustained acquisition for high camera frame rates. And as soon as the CPU is offloaded from any additional acquisition efforts, this remaining CPU power can of course be used for application logic like high demanding image processing tasks. On the right side, you see 2 images. The top image is using the standard GigaVision protocol, which is based on UDP. So we see a pretty imbalanced CPU usage, especially the cores 3, 4, 5, and 6 are distributedly used. When switching on the TCP offload functionality, we still see some CPU load, but the big advantage there is that the CPU load only focuses on core 1 and core 2, and the rest of the core basically has 0 to none usage, which allows for a constant CPU load balancing, and this also allows for pretty reliable processing throughput, of course. This TCP offload functionality, as mentioned, is a co-development between STEMMER Imaging and Allied Vision. So at the moment, this only works together with the CVB Image Manager and Allied Vision Gigi cameras. But we're also putting this into the IBSM meeting, which is happening pretty soon in Vienna, and hoping for standardizing this pretty neat feature which we came up with. So the next quite interesting USP there is that we are able to acquire images from MIPI cameras using GenICam compliant driver setup. This is also a development by Allied Vision. So they basically provide a GenICam compliant transport layer with their MIPI cameras, and this allows for seamless integration of MIPI cameras into our generic image acquisition engine. Those of you who already did their first steps with MIPI CSI2 cameras, they might know that integrating those cameras requires quite some programming, perhaps even low-level hardware programming skills. And those high engineering efforts get even worse, especially when switching from one MIPI camera supplier to another MIPI camera supplier. But with the GenICam compliant layer, which is available there, we are really able to seamlessly integrate those MIPI cameras into our ecosystem. So this really means that with the image manager, which you provide with the board, you can seamlessly switch from a MIPI camera to a GigaVision camera to a USB 3 vision camera without the need of reprogramming your code or basically zero to none programming or engineering efforts. And third and last but not least, there's this pretty neat showcase which we did a couple of months ago. This is a line scan application connecting a high-speed line scan camera via GigaVision to our modular embedded board. So there's a pretty high-speed image acquisition happening there. Using our image manager interface, we load the images directly into the GPU of our embedded board. So the driver directly puts the memory of the images into the GPU, which allows for high-speed image transfer and also high-speed pre-processing on using the NVIDIA processing unit. There's plenty of algorithms pre-available in CVB for making use of the NVIDIA. In this showcase, we just simply applied different filter algorithms to do some data reduction on the NVIDIA GPU, but we also do H.265 compression for high image quality, but still to reduce the data rate, which we can then send out using a video stream to a web streaming server, for example, for image visualization. So we make use of the Xavier NX 384 cores there. And we are able to provide full HD data reduction at a frame rate of 30 frames per second. So it's a pretty high-end application, really acquiring images at very high speed, doing local data reduction and pre-processing, and then providing a lower data stream either using H.265 again, or let's say a GigaVision server, for example. So this is a typical showcase of high-speed line scan application at the edge, where we have small computing units at the edge, at the line scan camera for pre-processing, for data reduction, and then also providing the data to the outside world. So those are basically those five major USP for our modular embedded ecosystem offering. It comes with a fully featured carrier board. It allows multiple interfaces, 2x 10 gig, 2x USB 3, 2x MIPI, which allows for a very broad application scenario. We are manufacturer independent, so we can get whatever hardware you need from STEMMER Imaging. We call it one-stop shop. It comes with a powerful software toolbox, and we also provide you with the services apart from the hardware and the software. Before finishing my presentation, I want to make you aware of our Embedded Vision Labs. This is an exclusive customer event, which we have on March 15. It's already in 3 to 4 weeks from now. This takes place at the evening, starting 6 p.m. right after the Embedded Worlds in Nuremberg. So everyone visiting the Embedded Worlds and who wants to get a more deeper insight about our embedded offering, please feel free to register at STEMMER Imaging. We are very happy to welcome you there and to give you more deeper insights about our offering in embedded. We also have special technical people there. So it's not just a marketing event, but also a techie, nerdy event, so to say. So please register, and we are happy to welcome you there. Thank you very much.